We will now try to describe the shape of this graph as comprehensively as we can. But first, we need to determine at different point of times what the displacement is first to understand the relationship. Right. So I already picked two coordinates. One is at time equals 5 seconds. Okay, at time equals 5 seconds. Right, and at time equals 10 seconds. Okay, at time equals 5 seconds, at time equals 10 seconds. Okay, at time equals 5 seconds, my displacement is 20 meters. And at time equals 10 seconds, the displacement is 30 meters. Okay, so when you look at this change in time, when the time increases by 5 seconds, the displacement increases by 10 meters. Right? So we can say that when time increases by 5 seconds, displacement of object increases by 10 meters. Okay, so when time increases by 1 second, displacement of object increases by 2 meters. It increases by 2 meters. But we will try to describe it as comprehensively as we can. Alright? So when the displacement of object increases by 2 meters, that means it's moving further and further away from this origin. Right? So this displacement of object increases by 2 meters away from its origin. Okay? Now, note that we are dealing with straight line graph. And in straight line graph, we do know that the gradient is constant. Right? We're dealing with straight line graph. And because straight line graph, we know gradient is constant along all points on graph. Okay, as long as it's along the same straight line. Alright, along the same straight line, the gradient is constant. And I can just show you a quick one. Gradient is constant. Because this gradient that I draw here, this is run. Right, from 0 to 5. And that's 5 minus 0 equals 5 seconds. This is rise. It's 20 minus 10 equals 10 meters per second. So the gradient equals rise over run equals 10 over 5 equals 2 meters per second. And I'm going to use another set of coordinates, right, to show you that, well, it's the same. Okay, the gradient is the same. And I'm going to extend from 0 to 10 seconds. Right, and this is my right angle triangle. This is the rise. And this is the run. And the run is from 0 to 10 seconds. So it's 10 minus 0 equals 10 seconds. The rise is from 10 meters to 30 meters. So 30 minus 10 equals 20 meters. So gradient equals rise over run equals 20 over 10 equals 2 meters per second. Okay, so it's constant, right? Therefore, we can say the displacement of the object increases at a constant rate of 2 meters away from its origin for every 1 second. It increases at a constant rate of 2 meters away from its origin for every 1 second. Constant rate. Oops. Constant rate. Right? Constant rate means it's a straight line graph.